Hello and welcome to EBRD's COVID-19 Resilience Framework Training Programme. This is video 2, which focuses on electrical supply and the distribution sector. My name is Stuart Hume from a company called Environmental and Social Advisory Services, or ESAS. And for the purpose of this video, I am joined by my colleague Alan Phillips, who is a specialist in health and safety. Alan, please introduce yourself.
Hi, my name's Alan. I'm a consultant with over 20 years experience of undertaking due diligence and monitoring assignments, including a number of assignments on behalf of EBRD.
Thank you. So let's now move on and introduce the video. So the purpose of the training video is to illustrate how EBRD's environmental and social policy and the accompanying performance requirements can be applied during an environmental and social assessment of a project within the electrical supply and distribution sector. The example used here is the upgrade and automation of existing electrical substations. So let's now introduce the project. The project involves the upgrade and automation of 10 electrical substations, and the aim is to improve the reliability of electricity provided to businesses and residents. Now, due to the automation of the substations, a large part of the workforce will be retrenched. Now let us look at the applicability of the PRs to this specific example. So firstly, PR1, the assessment and management of environmental and social risks and impacts. Well, PR1 always applies, and this project was categorised as a Category B project, and a detailed environmental and social assessment was completed. So moving on to PR2, labour and working conditions. Well, PR2 applies as well, due to the use of a workforce for the upgrade works, and also from the future workforce retrenchment programme. Now, with any project such as this, a variety of companies will be involved, and so the management of different contractors involved in the project is going to be a key issue. PR3, resource efficiency and pollution prevention and control. Well, PR3 applies as well, due to the project's use of resources such as water, and also from the presence of hazardous substances such as polychlorinated biphenyl, which is used as a cooling fluid within electrical substation equipment. We'll come on to that later on. Alan, please talk us through the applicability of PR4.
PR4 is directly applicable because there'll be works in and around live electrical systems, so the workforce will be exposed to hazards associated with live electrical equipment and electromagnetic fields. Additionally, there will be the need for multiple heavy lifts as part of the installation methodology and the use of road vehicles to transport equipment to site.
Thanks, Alan. And so moving on to PR5, land acquisition, restrictions on land use and involuntary resettlement. Well, PR5 doesn't apply because all of the upgrade works will take place within the physical boundary of the existing substation facility. PR6, biodiversity conservation and sustainable management of living natural resources. Well, PR6 doesn't apply because no additional land is required. In relation to PR7, Indigenous peoples, well, PR7 doesn't apply either because there are no people in the project area that meet the PR7 applicability criteria. Moving on to PR8, cultural heritage, well, PR8 does apply because the project involves new excavations and the potential damage to buried cultural heritage artefacts. PR8 also applies to this project due to the presence of some murals, which we will see in some photos coming up. And finally, PR10, information disclosure and stakeholder engagement. Well, PR10 always applies, and for this project, a comprehensive public disclosure and consultation process was undertaken. Key issues of stakeholder concern include the extent of future job losses due to the automation of the substations, and also when the more reliable electricity was going to become available to them. And now let us look at the application of the PRs to this specific project. So using the project, we will explore the application of PR 2, 3, 4 and 8. And there are a couple of photos here provided. The first reflects a lack of secondary containment under the electrical transformers that contain cooling fluids. And these cooling fluids in turn contained polychlorinated biphenyl, which is a persistent organic pollutant. And on the right is an example of one of the murals or pictures from the Soviet era. And this specific example reflects the culture of rural life and the natural environment. Now let us move on to task 1, the review of existing information. Well, under task 1, a variety of information was requested from the client, and in relation to PR2, labour and working conditions, this included details of their existing human resource policies and procedures, as well as details of the current and future workforce, bearing in mind that the workforce was going to be retrenched in part due to the automation of the substations. So all information associated with retrenchment planning was requested. Now moving on to PR3, resource efficiency and pollution prevention and control, well, information requested from the client included details of previous site investigation reports to check the quality of soil and groundwater in the vicinity of the electrical substations, and also a copy of their hazardous substances inventory and associated management plans. Alan, please take us through what was requested under PR4, Health, Safety and Security.
Well, the project risk assessment and risk register is always a good place to start. It helps you understand the extent to which the project understands the hazards and the risks. Additionally, documented safety procedures for work on live electrical systems, things like safe approach distances, authorised persons, access control, PPE specifications are also of critical importance. Given the site's history and nature, an asbestos survey is important, as are hazard control procedures associated with the risk of asbestos. The emergency preparedness and response plan is also important, as will be the contractor management procedure.
Thanks, Alan. And so finally, under PR8, Cultural Heritage, information requested from the client included a copy of the client's chance find procedure and also their cultural heritage management plan to explore whether there was any existing protection for the murals. And so now let us move on to task 2, site visit and discussions. And so moving on to PR2, labour and working conditions. Well, the due diligence included a variety of interviews with workers. Now, the aim of the worker interviews was to gain an understanding of how the client's human resources policies and procedures are being applied and how consistently they are being applied across the workforce. Ideally, the selection of workers should include those directly contracted to the client, as well as workers within major supply chain companies, to explore whether there are differences in how the workforce are being managed. As a general comment, conducting interviews with workers requires careful planning and sensitivity. Particularly, it's important that cultural sensitivities are respected. So, for example, females on the side of the environmental and social consultants should be interviewing female workers. The PR2 guidance documents provide some more information about the interview with workers, along with some questions that you may wish to ask. In this case, the worker interviews indicated that existing substations are too hot or cold, and this has led to consistent complaints that have not been addressed by the client, and so it was, if you like, a recurring grievance. Whilst the worker grievance mechanism had been implemented, not all workers were fully familiar with the process. And of additional concern was the way in which the retrenchment would be implemented by the client in the future due to the automation of substations. And PR2 under paragraph 20 contains some specific requirements associated with the planning and implementation of a retrenchment programme. And so now let's move on to PR3, resource efficiency and pollution prevention and control. Well, there was the potential for soil and groundwater pollution to have occurred from leaking tanks containing transformer oil. These relate to the PCB cooling fluids that we discussed earlier. The client had identified a variety of third-party waste management companies to collect and dispose of the old electrical equipment, although no audit had been undertaken by the client to check that they had the technical capacity and the ability to dispose of the old electrical equipment in an environmentally responsible manner. Some of the substation sites also experienced significant flood events due to a lack of adequate drainage, and some of the sites are also handling sulfur hexafluoride. Now, this is a very specific type of gas widely used to prevent short circuits, as it is an excellent electrical insulator. However, it has a very high global warming potential and is currently banned across the EU for any use apart from as an electrical insulator. And so the overall management of SF6 was something to focus on during the due diligence exercise. Alan, please take us through the PR4 issues.
The project has developed a risk assessment and risk register, but key gaps have been identified, including the risks associated with the use of contractors unfamiliar with the site and the need for pre-work instruction training and active supervision. Exposure to hazardous materials and energies, including asbestos, polychlorinated biphenyls, and electromagnetic radiation. Asphyxiation associated with the release of sulfur hexafluoride. Dusting to live infrastructure, which could lead to unreliable operation and failure. The reliability of the existing firefighting system, it appears poorly maintained and corroded, as you can see in the bottom picture. The assessment needs to consider the suitability of extending this firefighting system to the new infrastructure. The safety procedures for work on energised systems are old and in need of update. Notably, there is no permit to work system. Furthermore, tag out and lockout, a common good international practice, is not used. Instead, wooden barriers are put in place to prevent workers touching live electrical apparatus, as you can see in the right-hand photo. A good tagging system to advise workers of the status of equipment is essential, as is a lockout system which guarantees isolation, especially when contractors are unfamiliar with the site. Where enclosures do have locks, the keys have been routinely left in cabinets. The keys are not under the control of a competent person. Furthermore, safe approach distances and access control measures to live equipment is not specified, and there is no documented contractor management procedure. Moving on. During the site visit, the following observations were also made. The concrete supports and poles are heavily deteriorated, and phase and conductor brackets are heavily corroded. Stability and structural integrity needs to be considered, assessed, and the working method adjusted for the removal of conductors to avoid pole or support failure due to change in structural load or forces. Risks associated with the presence of hazardous material needs to be understood. For example, asbestos. This needs to be communicated to workers, including any risk control measures to be used. Safe approach tagging is not used to identify live systems. This is especially important for workers unfamiliar with the sites. Cable racking or goalposts are not being used where vehicles are moving under live conductors, and you can see from the bottom right-hand picture evidence of vehicle tracks underneath high voltage lines. The installation method also requires heavy lifting equipment, and from the top right-hand corner we identified a number of concerns. Firstly, there is no documented lifting plan. Lifting operations are not supervised by a trained, competent signaller or banksman, which is also known as a spotter. The client does not provide constant supervision of lifting operations by a competent electrician familiar with the site. This is critical given the presence of live electrical systems and a contractor who is unfamiliar with the facility. Loads are being lifted near live conductors. These live conductors are not tagged or wrapped. And again, safe approach distances are not defined and barriers to prevent access are not being used. The loads are not secured by qualified and competent riggers and slingers. And from the photo in the top right-hand corner, you can see that this heavy load is not being secured during the lift. Furthermore, wind and weather conditions are also not monitored during lifts. There is no maximum permissible wind speed.
Thank you, Alan. And so now moving on to PR8, Cultural Heritage. So the electrical substations that were to be renovated included a variety of cultural heritage artefacts. On the left, we see a stained glass window which includes a dove seated at the top of an electrical transmission tower. And on the right is an outdoor mural of a worker holding a shining bulb, and in the background you can see a combination of industry and nature working in harmony. Now these artefacts date from 1962 and are currently in a very good condition, but there was a risk that they could become damaged during the upgrade works. Now there is, for community health and safety reasons, no public entry to the substations, and so none of these artefacts are currently on display to the public, and they won't be in the future, because even when the substations are upgraded, public entry will still be prohibited. Now there is a Soviet cultural art organisation within the Ministry of Culture, and this had been identified as a stakeholder by the client. There are of course various options as to what to do with the cultural artefacts. Firstly, protection during the construction works is key. It's unlikely that they could be removed without damage to their current physical condition, but there's also a potential for photographs to be made and for some form of photographic display with information cards to be presented and available to the public. So now let's move on to Task 3, Analysis and Reporting using the EBRD format. So this is where the information gathered during Task 1 and Task 2 is collected and analysed. And so the following gaps are identified that needed to be addressed in the Environmental and Social Action Plan. The first was to prepare a retrenchment plan. Now EBRD's Environmental and Social Policy Framework, PR2 paragraph 20, contains some very specific requirements associated with collective dismissals. These include, for example, the analysis of alternatives, the preparation of a clear and transparent selection process, the use of a grievance mechanism, and for all outstanding back pay and social security benefits and pension payments to be provided, amongst others. The client also needed to implement a soil and groundwater investigation program to check for the presence of contaminated land under and surrounding the previous electrical transformer equipment containing PCBs, and an audit on the third-party waste management facilities and companies that were to be used for the collection, treatment and disposal of the old electrical equipment also needed to be undertaken. Specific sites needed a flood risk assessment undertaken to improve the flood management, and the client also needed to prepare a sulfur hexafluoride management plan. Secondary containment bunds for some hazardous liquid storages across the sites were also required. And in relation to the murals, a cultural heritage management plan should also be prepared through consultation with key stakeholders. Alan, please take us through the findings in relation to PR4.
The risk assessment needs to be updated to include all project risks, including the use of contractors unfamiliar with the site. Safety procedures need to be improved and updated to reflect current good international practice and effectively implemented. The suitability of existing firefighting systems must be audited, assessed, and upgraded and maintained as necessary, given the requirements of the new infrastructure to be installed. The project needs to develop a contractor management plan, which includes supervision and oversight activities, clearly specifying the method to be adopted and frequency. Asbestos needs to be identified and removed before works commence, to the extent practical. Structural assessment of all poles, supports and brackets needs to be undertaken. The findings of this assessment must be used to prepare a method statement for removal of old conductors to reduce the risk of collapse due to change in structural load. And finally, a lifting plan must be developed, which in addition to the usual good international practice requirements, includes authorised routes and locations for mobile plant and cranes and safe approach distances for workers, given the presence of live electrical systems.
Thank you, Alan. And so as we close, let's just take a final look through at the application of the PRs to this specific case study. And as we've discussed, PRs 1, 2, 3, 4, 8 and 10 all apply. This is the end of video 2. I hope you've enjoyed it. Thank you very much.